Okay, the binomial expansion and knowledge of Pascal's triangle is important, but we're going to use nCr here, your combinations. So let's get started. Let's do the maths. So I'm going to be using, let's make sure we have the right, there we go. That's okay. I'm going to be using a plus b to the n is equal to, and well, we've got the sum of, and of course n and r is equal to 0. And well, we're using our nCr, where a to the n minus r and b to the r. So we need to identify, of course, our values of a, b, and n. Well, here's a, which is the 2, and here's b, which is x, and here's n, which is 4. So a is equal to 2, b is equal to x, and n is equal to 4. So we're going to sub that into the expansion. So subst in expansion. And when we do that, what do we have? Well, we have our question, which is 2 plus x to the power of 4. Well, that's going to be equal to 4, using nCr, 4c0 and 2 to the power of 4 and x times x to the 0. And then, of course, we have 4c1. We've got to add each term, 4c1, and 2 descends here, 2 cubed, and x, and it ascends in powers of x, sorry, and plus 4c2, and again descending 2 squared and x squared, because that ascends, and then plus 4c3, and we're going down now, so it's 2 to the power of 1 and x cubed. Let's scroll down, and we're going to add 4c4, and that's 2 to the power of 0 and x to the power of 4. And what does that equal? Well, in the first one we've got 1, and we could use Pascal's triangle, but I'm doing it nCr way. 1 times 1, and of course times 16. Plus, we've got 4 times 8x. And then plus, we have 6 times 4 x squared. 6 multiplied by 4 x squared. And what about our cube term, x cubed? Well, we've got 4 multiplied by 2, 4 multiplied by 2 x cubed, because it's 2 to the power of 1 and x cubed. Oh, I've run out of space here, and then I'm adding to the power of 4. Well, 4c4 is 2 to the power of 0, so that's going to be 1 times 1 and x to the power of 4. And it doesn't look like a 1 there, so I've just got to change it. Again, everything's in real time, so we alright, there we go. And let's make sure that that looks more like a 1, because 1 times 1 x to the power of 4. So it's not good. Okay, and that's equal to, what's it equal to? Let's just scroll down and let's try to evaluate that. That's equal to, we've got, let's move this down a bit further, and we've got that equal to, well, we've got 16 plus 32x, yeah, 32x, plus 24x squared, plus 24x squared, plus 8x cubed, plus 8x cubed, and plus x to the power of 4. So that's our binomial expansion. And that's the answer for 3 marks. Let's have a look now at a second question. And we're just going to do some examples of this because I've been asked, and we're starting off with it medium pace, nothing too complicated. So let's move that out of the way. Find the coefficient of the term in x cubed in the expansion of 2 minus x brackets to the power 8. So again, I'm going to use the good old nCr. Let's have a look at this and see how we can apply it here. So again, I'm going to write out and tell the examiner what I'm going to use. A, because I like this, a plus b to the n is equal to, again, the sum of n, r equals 0, and nCr. I'm going to use good old nCr. Again, which is a to the n minus r and b to the r. Now, a is equal to, what's the values here? Again, a is equal to 2, a is equal to 2, b is equal to minus x or negative x, and and n, apologies, n is equal to 8. N is equal to 8. So, x cubed, now the x cubed term here, we don't need to worry about substituting. We're going straight because it says find the coefficient of the term in x cubed. Well, x cubed, the x cubed term occurs when r is equal to 3. X cubed happens or occurs? Occurs when r is equal to 3. So therefore, I'm going to say, using nCr, 8c3, yeah, because we got to the power of 8, is 2 to the 8 minus 3, because it's n minus r, and n is 8 and r is 3. So n minus r is 8 minus 3, and by negative x cubed. By negative x cubed. Excuse my writing here. Negative x cubed. So, what does that give us? That gives us really 56 times 32, or you go straight to your calculators here now, is equal to 56. I'll write it out, tell the examiner what I'm doing. 56 times 32 and times minus x, or cubed, and that gives you the answer of minus 1792 x cubed. So the coefficient then is minus 1794. Therefore, the coefficient is minus 1792. And that's it for three marks, I believe. That's it for another 3 marks. One final question. Find the first 3 terms in ascending powers of x in the expansion of 3x to the power of 4. 3 plus x to the power of 4. And again, this is another standard question. And what am I going to use? I'm going to be consistent here. I'm going to use, again, a plus b to the n is equal to n, r equals 0, and I'm going to use nCr. Again, a to the n minus r, b to the r. And what's the value of a? A is equal to 3 plus x, so b is equal to b is equal to x, and n is equal to 4. And well, therefore 3 plus x to the power of 4 is approximately, because whoops, I didn't write 4 correctly here. Let's do it better. 4 is approximately equal to, we write 4c0, 4c0, 3 to the power of 4, x to the power of 0. We do our expansion again, and then we're going to add 4c1, 4c1, again 3 cubed, we're descending in powers of numbers and ascending in powers of x, x to the 1. And we're going to add 4c2, and then 3 squared, and x squared, and one more. Oh no, we stop there. We stop there because we only want it to power 3. So that's enough. And what does that give us? So that gives us approximately 1 times 81. You can go to your calculators. You don't have to be slow and boring like me. Whoops. Again, I've messed up the writing. 81. It doesn't like 81. 1 times 81 and times 1. Plus 4 times 27. Plus 4 times 27 multiplied by x, and plus 6, oops, that is a plus, 6 times 9 x squared. So, and that gives us, and we're up to 12 minutes, we've gone over time. I don't want to take too long because I'm scared that I'll bore you all. Because this is just a part 1. It's an introduction to the expansion, and this will give us approximately equal to 81 plus 108x plus 108x and plus 54x squared plus 54x squared. And I believe for 3 marks, find the first 3 terms in ascending powers of x in the expansion of 3 plus x to the power of 4. Yeah, 81 plus 108x plus 54x squared. Okay, little bit over time, but that's I think a nice part 1 to the binomial expansion at A level.